We are going to solve two problems. In first part, this mathematics problem related to logarithm. Also, we need for finding order of time. For example, in some problems of coding like USACO to be able to work with logarithm. In second part, we will solve this problem of USACO and we will consider important ideas that are useful in also USACO 2023, 2024, and so on for preparation for these exams. Okay, if you want to learn other important ideas, feel free to send message to my WhatsApp number in the description. And you can use the chapters or time codes in my video to go straight forward to the part that you want. So let's just start with problem 1. X is a real number such that log x to the base 3 plus log x to the base 5 equals 8. Find x. For this one idea or identity, we can say it's log a to the base b times log b to the base c. You can cancel these two b's. So it will be log a to the base c. And as a result, we can say log a to the base b equals, let me write it here, log a to the base c over log b to the base c, okay? Or usually we write like this, log a over log b with equal bases. This c can be any number. And if you multiply b will be cancelled. It will be, if you cross multiply, it will be log a to the base c by first idea, and they are equivalent. Here, when we have like this, because the bases are different, I write log x over log 3, and we know the bases are equal. For next one, log x over log 5. And at the end, we will select which base is better, or we can select one base, for example, 10, it's not important. Equals 8. In next step, we use common denominator, okay, and we factor from log x. First step, it will be 1 over log 3 plus 1 over log 5 equals 8. Now, if we multiply both sides by log 3 times log 5, left hand side will be what? If we apply that, it will be log x times log 5 plus log 3 equals 8 times this, 8 times log 3 times log 5. Now, for this part, we should use another identity, log a plus log b when bases are equal equals log ab. Okay, so for this part, okay, if you apply identity or idea 3, we can say log x times here, log 5 plus log 3 is log 15 equals 8 times log 3 times log 5. So log x is what? We should divide both sides by log 15. It will be 8 times log 3 times log 5 over log 15. We don't want to use calculator. Okay, so here for calculating this, you can say, okay, by definition of logarithm, idea 3, identity 4, if log a to the base b is n, it is equivalent that b to the n is a. Now, we can consider, for example, all bases should be same. All if bases if equals 10, you can raise 10 to the power of this and this, but because here we have 3, let's consider base 3 for all of them, okay? We will see why. Identity 5, we can also use definition log b to the base b is 1 because b to the 1 is b. Look, b to the n should be a. b to the what is b? b to the 1. So we can say it is equal to what? Log x to the base 3 equals 8 times log 5 to the base 3 over log 15 to the base 3. And now if you raise 3 to the power of this, We know that 3, for example, b to the power of log b of a, it is equivalent to this, is a. Okay, because it is n, b to the n is a by the definition. So 3 to the power of log 3 x to the base 3 equals 3 to the power of 8 times log 5 to the base 3 over log 15 to the base 3. 3 to the power of this by this identity is 3, is x. So x equals this part, and you can say it is equal to 3 to the log 5 to the base 3 to the power of 8 over log 15 to the base 3. Okay? And you can do that. Why? By power rule, obviously, because a to the power of mn equals a to the power of m to the power of n. So 3 to the power of this by using identity 6 is 5. So 5 to the 8 over log 15 to the base 3. Also, you can write it as 5 to the 8 with radical 15 over 3. The root is this. All of these are answers, okay? So our answer is this, 5 to the power of this real number. Also, we can write 5 to the power of 8 over here. You can write 15 as 3 plus 5 by using idea 3. We can write it log 5 to the base 3 plus log 3 to the base 3 instead of 15. And we know log 3 to the base 3 is 1, so 5 to the power of 8 over log, let me write this, it's 1 this one plus log 5 to the base 3. Also, it is our answer. Okay, now let's try this problem of USACO and let's consider important ideas of that. Okay, read this problem. I will explain. It says we have some conditions like this, and in each condition we have at most we can check at most one variable. Here is important. You should check at most one input variable for each condition, and here one of them, one of them, one of them. For example, in this case, b0, b1. If we have 0, 0 for the first one, 0, 0, 0, 1, 1, 0, 1, 1. Let's see the result is 1. It says if b1 is 1, return 1. So b1 is 1 for this one, 1, return 1. Now for other cases, else if b0, 0, and this one b0, 0, return 0, else return 1. Okay, so the results are this. Now it says, okay, we have results. You should see, can you find a code like this that satisfies all these results? So let's check. For example, let's say this one. If it is okay, you should say okay. If not, you should say lie. For first one, it says 1, 3. So when it says 1 means we have only one variable. So b0. If b0 is 0, then result should be 0. If b0 is 0, result again should be 0. So they are equivalent. If it is 1, 1, so we can type this code. If b0 is 0, then like here, return 0, else here like this one, the last part, return 1. Or you can say else if b0 is 1, return 1. So this one is okay. And we can see the first one is okay. We've checked. Now let's check second condition. 0, 0 means b0, b1 if 0, 0. Result is 0. If it is 0, 1, result is 1. If it is 1, 0, result is 1. If it is 1, 1, result is 1. Okay. So we will see only for this condition it is 0. So you can say if, for example, b0 is 1, like these two things. Return 1 else, now we know else B0 is 0. So for B1 0, it will be 0. So else, if B1, we can check this one or this one, both of them correct. For example, I say, okay, this. If B1 is 1, again, return 1. Else, return, so this else means what? B0, 0, B1, 1. B1, 0. Return 0. It will be this case, okay? So now this part is for this one, pink one. This part is related to this one. The next one, orange one. This one related to this one. Okay, so it will be okay again. And we've checked second one. Now for this one, always let me tell you something that is important. Check input out. They help you. These things helps you to understand problem better. So next one, 1, 2. Okay, 1, 2 means we have only B0, 2 conditions. 0, 0, the result should be 1, 0. So it's not possible, obviously. Because if we check, for example, if B0, 0 for 1 input, you have 2 outputs. Okay, 1 and also you have 0. So obviously it's not possible because when you consider 0 as input, the output is unique because it's like a function. So it will be lie. Now, for this one, we can say what? Maybe check this one. For this one, you say, okay, B0, B1, 0, 0, 0, 1, 1, 0, 1, 1. And let's see the result is what? Is 0, 1, 1, 0. Okay, let's check. Here in first part, we want to check one condition. Okay, so first you check a condition. You say, for example, if B0 or B1 without loss of generality, you can say, for example, without loss of generality, if B0 equals 1, then you should return something. Look, the problem says if you consider each of them, let me show you. Okay. Each statement examines the value of at most one input variable and returns either 0 or 1. Okay, so we should return one of them. So in first case, if you, for example, say for first condition, it returns what? Because when B0 is 1, we have these two cases and the output is both 1 and 0. If you check B0, 0, we have these two things, then we have two conditions. If you check B1, for example, instead of B0, let me consider this one. For example, if B1 is 0, so let's see what happens. B1, 0, these two conditions, the result can be 0 or 1, so we cannot say 0 or 1, return 0 or 1. If B1 is 1, let's consider this one. Again, we have same problem. Because B1, 1 is related to these two things, then we have both 1 and 0 for results, so we don't know what. We should return what. Okay, so for first condition, we have problem. So we proved that this one is lie. Now we want to see the algorithm is what. And as you can see, n is at most 100, the length of a string, and m, number of conditions that we should check also is at most 100. Number of test cases equal to what? 10. Okay, so t, number of test cases is at most 10. N and m are at most 100. So for example, order of nm or nm squared will be okay. And here, let me also check something else. We've considered, for this one, for example, test case, t is this one is n, this one is m. Number of conditions that we have, here it says nn. Okay. Let me explain for you the algorithm is what. Let's consider an example. In that example, I will explain my algorithm is what. Suppose last column is the result. So for this one, 1, 2, 3, 4, 5, 6, 7. M7 is number of conditions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is 10. So let's fill this table. For example, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1. 1, 0, 0, 0, 1, 0, 0, 1, 1, 1. For example, this one is 1, this one is 0, and this one is 0. For example, 0, 1, 1, 1, 0. And the next one, we can fill this one 1, 0, 1, 1, 1, 1, 0, 0, 0, 0. Next one 0, 1, 1, 1, 0, 0, 1, 0, 1, 0. Next one is 0, 0, 1, 1, 0, 0. For example, 1, 1. 0, 0. Next one is 1, 1, 1, 0, 1, 1, 0, 1, 0, 0. And last one is 0, 0, 0, 0, 1, 0, 1, 0, 1, 0. Okay. Now, if we pay attention to last example of problem here, we should find, for example, look for B0, 0, 0, it was different. Okay, we should find a variable that, for example, for all zeros, we have same thing. First condition. So for first one, you will see, okay, 0, 0, 0, 0 are these things. We have both 0 and 1. Okay. And for ones, for 1, 1, 1, we will see, okay, we have 0, 0, but for this one, we have problem. For next one, we have 1, 1, 1. So this one, 1, this one, 1, this one, 1. Okay, that's okay. So if we consider this one is B0, B1, B2, B3, B4, B5, B6, B7, B8, B9. So I say what? Okay, so for B1, I say, okay, if B1 is 1, then we can say result is 1. If B1 is 1, return 1. Okay, and because of this, we can erase this row, this row. Let me check with you. This one. And now you will see, okay, this, we have 4 zeros. We have both 1 and 0. Because this column B1, now for the rest of the, for example, rest of the solution, B1 has no effect. We shouldn't check B1 because 0, 0, it's always 0. So we can remove also this column B1. Okay, so let me do something. Okay, let's erase completely these cells. Okay. And we can erase this part. We will erase completely these rows and columns. Now we try again our conditions. So for first one, we will say, okay, these two ones always return 0. So for next one, if B0 equals 1, return 0. And now, again, we will erase these two rows. So for rest of the cases, B0 is 0, means it doesn't distinguish anything. So similarly, we can remove first column. Now again, if we consider, we know 1 is 1, 0 is 0, so we can check 2. We can say, okay, so let's try. Else if here, now because 1 is 1, 0 is 0, you say else if B2 is 1, then return 1, else return 0, and we can erase all these things. So by only using B0, B1, B2, we could satisfy all conditions. Now let me explain for you how to solve it in general. Okay, if I want to explain, it is our main table for the example. We check BI and result. So it can have 0, 0, 0, 1, 1, 0, 1, 1. So if for one column, all of them are same. Okay, for example, if we have at least one of them. Okay, suppose we have at least one row and at least one column for these parts, means at least one BI and at least one row. So if you have only one condition, like this, it means what? Without loss of generality, suppose that if you have one condition, we have this. So you say if BI is 0, result is 0, and then it satisfies all of them, and then it will be okay. Okay, so if for one column we have this condition, the problem will be solved. If we have two conditions, again without loss of generality, suppose that we have one of them is the first one, the other is this one, or the other one, this one and this one are similar, 0, 1, one bit different. This, if we have this. So for second case, for this one, as you can see, it is always 0, so it has no effect on rest of that. And also for some cases, it's 0, it's 1. So you should only focus on other cases. So for this one, we should remove column of BI because it has no effect. It is always 0. Sometimes the result is 0, sometimes 1. You should focus on rest. Now for this one, this and this. So for 0 and 1 it is not important. BI is what? The result is always 0. So you should say, for example, return 0. Okay? And this one will be okay. Now, we should also check case 1 and case 3 because when you check case 1 and 2, BI are same. Let me tell you also this case. For this case, you say, okay, we have this condition and this condition. So always the result is 0. So this one again will be okay. You return 0, okay? Because it says the input is at most one variable, you don't say anything, you say return. If for this case, all of them 0, you say return 0. Okay? Now, let's check if 3 conditions are satisfied. So again, without loss of generality, suppose one of them is this, so we should check this case, and this case. Let's start from first case, this one. So for this case, as you can see, we have this one, this one, this. 0 can have 0 or 1 as a result. 1 can only have 0. So you say if BI is 1, for this one, if BI is 1, return 0. Okay, then all rows that satisfy this will be okay. And you can remove this part. So for this one, we have only 0, 0, 0, 1, 1, 0. And there are some rows like first one, some rows like second one, and some like third one. So when we apply this, we can remove these rows that BI is 1 and result is 0. And then you need to only focus on rest. And because for rest, BI is 0 always, it cannot distinguish. So you should remove BI. Remove BI and remove these rows. Okay? For next one, this one. It is related to this one, and last. 0, 0, 0, 1. So for 1 again, you should do the same thing. Here you should remove these rows because 1, 0, and this column. Okay, so again you remove, if it answer 0, 0, 0, 1, 1, 0. Let me check 0, this one, the difference is. Sorry. I said I should check here 1, 1. I forgot. Okay, so let's quickly check previous cases. So here 0, 0, it has no, it's not different. This one, this one, this one, this case. So because it's related to last one, this one was okay, this one was this. And for this one, we know 0, 0, 1, 1. Again, this, it will be okay. You say if bi is 0, return 0, else we know bi is 1, return 1. Okay, so this one again will be okay. And this one, okay, so this one is 1, 0, so this one. Now we should check this. 0, 0, 0, 1, 1, 1. Okay, we know when it is 1, we can say if it is 1, return 1, and then work on the rest. So you should remove these rows and this column, bi, and then work on the rest. This one, we have 0, 0, 1, 0, 1, 1. For this one, you again, if it is 0, you return 0, and you remove these rows and this column again because the rest is always 1. Okay. So for these parts, we've explained what should we do. And now, if we have all 4 conditions, we cannot do anything. Okay, and if all of them looks like this, if all of them look like this, all of them are satisfied, we have 0, 0, 0, 1, 1, 0, 1, 1, then it will be lie. Okay, we should consider lie as output. Now let's see. So maybe we reach, for example, an empty table. If we reach empty table, it will be okay. If we remove, look, in each case, we remove here. Here it was result. Here bi. We remove some rows and some columns. If all rows are deleted, again it will be okay. Now, like this. Why is it all rows? Because empty table means all rows and all columns. Here means only all rows are deleted. Now suppose if all columns. Why we say this? Because in these conditions here we can remove or it will be okay. The only condition that is satisfied is this one or we remove something. So if we have this, we print lie, but sometimes we remove. And for example, we reach a case that there is no row or there is no column. If all columns are deleted, then suppose we have some rows. The table will be like this, for example. Without lots of generality, we remove, for example, this column, we remove this column, all these things, and we remove these rows. Now, these rows are left. If the rows that are left, the result is all of them 0, this part, for example, let's call this part that is A, we have these rows. If A is completely 0, okay, or if A is completely 1, it will be okay because we cannot check any other BI. But if 1 belongs to A and 0 belongs to A, then it will be lie because we don't have any BI to satisfy that. So we've considered all these cases. Now, if we want to see how we can apply this code, it is the code and different parts. Mark C shows, for example, which columns are deleted, mark R which rows are deleted. This one, different functions. We update each in each part, and you can see all codes will be like this. Okay, is the correct code. If you want to learn more or want to learn more important ideas, for example, DAG, topological sort, and many other things in computer programming, or preparing for USACO, or also if you want to learn important ideas for USAMO or IMO, feel free to send message my WhatsApp number in the description. Okay, thanks for watching this video. Please don't forget to subscribe, turn on the bell, and like the video. Thanks. And let me tell you a homework. For next homework, consider log 2 of x plus log for x to the base 3 plus log x to the base 5 equals 10. And then x is what? Solve this one and comment your answers right below this video. Okay, have a great day. Bye.